Hello, my name is Zoe Turner, and this is my lab on presentation. And in this lab, we observe an object moving at the same speed without changing direction. And we do this to observe its observed position versus time versus the predicted position versus time. And so when we go into this, we ask, why? Well, we do this to expand our knowledge on how Newton's second law is used throughout in physics. And so without further ado, let's go on to the data in Tracker and Glowscript. So in Tracker, I observed a motion of a marker moving across a table at a constant speed. And this video is very short, but as you can see where the little diamonds are, that's me tracking its position at certain times. And as you look at the Y chart, you're probably wondering, why does it go up, down, and at some parts it's straight and at other times it's decreasing? Well, because when I plotted the position, it wasn't in a completely straight line. But luckily for this lab, the Y isn't what we're focusing on. We're only focusing on position on the X coordinate. And so I asked myself another question. What if the X's were flipped? Well, if this Y-axis was this way, I'd believe the graph, instead of looking from this corner increasing up, I think it would go from the top corner increasing down. I believe this because the way we graph position is whether the object is moving towards the origin. So if the values are negative, it's negatively moving towards the origin instead of away from it. Now into our Glowscript code. I weighed the ball, which is 0.5334 kilograms. And the position always starts at 0. Also, the velocity, I found that from the first and last lines of data that I found in Tracker. So I did V2 minus V1, or not V2, position 2 over position 1, or position 2 minus position 1 over time 2 minus time 1. I did this so I could find, because velocity is constant in this lab. And so I did that to find just the velocity. And we don't really need momentum principle to keep updating velocity because it's constant, but we need it. We absolutely need it to update position at every time interval, which is at 0.1 seconds, which is what I made delta t. So without further ado, let's continue on. When I run this program is very fast because it's doing it out of 0.1 seconds. I did this so it's easier for me to graph. And as we see in this chart, everything is constant. And in the velocity is constant. This is because we only use one velocity. Now, when we look at the two graphs separately, we can see that it's almost the exact same. The only difference is in our observed position that at some point the speed slows down or speeds up. This is because that in our Glowscript chart, we set Fnet to 0, but in reality, Fnet isn't 0 because there are other forces acting upon it that wouldn't make it 0. So in conclusion, that the observed position isn't truly constant, but the predicted position is. And to make the predicted position more like the observed, we would have to take into different intervals on here, so from 0 to 0.25, and take the velocity of that, and then update it from 0.25 to 5, or 2.5, and then 0.5 and 0.75, and so on and so forth for every little interval. And that's how we would be able to make it more, or make them closer together in time and positions. So I found that the flaw because of that. And in our past lecture videos, the predicted position is usually above observed because it's not truly what the position will actually be. And for the position to actually be the observed position, we would have to update velocity at the millisecond, so everything is completely on top of the other. Thank you so much for watching my video, and I hope you can stay to watch my Lab 2 video.